an ominous sunset as tropical moisture flows north through Texas. And yes, we have tropical moisture, a very strong polar front, and even a dry line west of Del Rio. The cold air is being brought in by this 1034 millibar high, currently centered over Iowa, with another center located over Montana. And this extending from North Carolina through Louisiana, out through the Rockies and back towards California, that's the polar front. The strongest portion, of course, is a little bit further to the north. You can see the temperatures in Tennessee, South Carolina, really not that cold. But it's only when you get north of the Ohio River, you go from 53 at Nashville down to 10 degrees at Champaign, Illinois. So we could probably draw a secondary front, something like this right here, through that region. That provides a little bit of distinction between this old stagnant polar air mass and the fresh incursion up to the north. And I've also done that up in the Pacific Northwest. If you take a look up here in British Columbia, the Fraser Valley, out towards Banff National Park, very cold temperatures up in that area, -10 to -20, and that's very close to Vancouver. However, it's being blocked by this mountain range right here, and that's keeping the cold air even out of northern Idaho, where it's in the 20s and 30s. Not much going on in the southwestern U.S. under this continental air mass, kind of warm, 50s and 60s in that region. But we go up to the north and we get into the heart of that Arctic air. That covers much of the Canadian prairies and pretty much everywhere up to the north except this little wedge around Baffin Island. And that's warm air that's recycled northward through Newfoundland towards the north and the northwest. If we keep in mind that there's this very large polar vortex over Canada, that means that this portion is going to flow southward, and this portion out to the east is going to flow northward. So as a result, temperatures are close to zero and even above zero out in the eastern part of the region. But out west, look at those temperatures. We've even got -55 there, pretty close to Whitehorse, Yukon. This entire region that you see here in blue, that's below -40. And then we have this outer band showing where it's below -20. And some of that extends over Manitoba and even Saskatchewan. A quick check of the webcams around Canada. We'll take a look at what a cold environment looks like. Well, where it's more mild, we'll go to Dauphin, Manitoba, kind of in this area right there. You can see it's about -10. There's what it looks like at this hour. Winds are still gusty out of the west, 20 gusting to 28. You certainly would not want to be outside. So we'll go northwest where it's even colder. Well, to get to -20, we can go up to the Edmonton area. And there you go. There's Edmonton Villeneuve Airport, -20 with winds also gusty. For -30, we can take it up to the Fort Nelson area. And there you go. That's a little bit further to the west near Liard River. Wow, it's very scenic. And you can see that there's a little bit of wind blowing. And to get into the heart of that -40 and -50 air, we need to go up to Yukon. There's Faro, Yukon, -42 Fahrenheit, with a calm wind. Also looks very scenic, and it looks deceptively warm. And finally, how about this station that's -51? Well, that brings us across the border into Alaska to a town called Eagle. -51 Fahrenheit, and again, that's without a wind chill. And that would be certain death if you were not dressed to be out there in that weather. One of the warmer spots in the country is the Orlando area, 85 there, and even 86 just to the southwest. But if you go up to the north, we do hit that front and temperatures fall into the 60s in the Florida Panhandle. The front, not very well defined out west. But if we pan out to the west, we catch some of the cooler air there in Texas. You can see the difference between Houston, where it's 74, and Dallas, where it's 34. The front located right through this area near the Interstate 10 corridor out towards the Texas Hill Country. And look at that, Ozona 73, and then about 40 miles away, 39 at San Angelo. Pretty significant difference. And for our viewers in Europe, that's about 23 Celsius versus 4 Celsius. And panning that further west, this shows the tail end of the front. So we can use charts like this to kind of identify what's going on as far as the air mass edges. So pretty clearly the front is right around this area here. You can see on one side very warm temperatures, on the other side cool and southeast to easterly flow. Further up the boundary, it does look like it is right in this area, eastern New Mexico, down the Texas-New Mexico border. And some evidence of maybe a cyclone right there around Tucumcari. Man, 62 at Las Vegas, New Mexico versus 26 at Clayton. And then further up the boundary, you can kind of see the effect of the shallow air there in the plains, 20s and teens out over the plains, and then you get into the mountainous areas, and it's actually much warmer. The warm spot in Colorado. Looks like Montrose there with 50, and 53 there at Cortez. So it's hard to believe if you want some relief from the cold weather, head to the mountains. And then further north there in Wyoming, some bitterly cold temperatures there around Casper, up to Sheridan and Gillette, and the warmer conditions found in the western part of the state. So our front is about like that, right near the Continental Divide. And things do get a little bit more complicated as we get out towards the western U.S. Looks like that Arctic air has moved pretty much right up to the Bitterroot Range. And then west of there, some cooler Pacific air working southward. And then we've got that secondary front somewhere out towards the southwest. And then putting that together, here's the visible satellite imagery. By doing that work through of the surface chart, we know that the front is right there in this area here. And you can see that the western edge is being eroded by a combination of heating, dry conditions, and westerly flow. See those edges right there. And of course, those will work back towards the west overnight. Looks like conditions are unsettled there in California. Looks like mostly mid and upper level cloud. Not much going on in the northwestern U.S. Fairly clear, some snow cover in the mountains. But you get out east of the Continental Divide and you can see that snow cover. And that's going to help reinforce some of that polar air that's coming south. The northeastern U.S. showing a cold advection pattern, and you can see right there along the shore of Lake Erie, picking up some moisture and heat, and producing some lake effect snows on the lee side. Similar effect going on there in Ontario, around London, all the way down towards Sarnia. And as you go further south, the cloud development is a little bit more baroclinic in nature. And then in the southeastern U.S., remember we have that front pretty much running right through this area, and you can see the drier air north of the frontal boundary, indicating that that is a heavily modified old polar air mass north of that boundary. And then down to the south, we've got the native maritime tropical air. So putting that all together, here's our workup of pressure and thickness. Pretty much like what we said on that opening surface analysis, this is actually 0Z. This is a 6-hour forecast, so this will be slightly different from what we saw on that surface map. The thermal gradient, pretty much running about like that, and some of it extending down into Texas. So based on this alone, we would be looking for a front somewhere in this area. That would be an occlusion off of the New York coast. We can see that depressed area of thicknesses off the California coast, indicating a cutoff low, mostly a mid and upper level system. And you probably remember last week where we talked about the value of heights and vorticity. Great way for finding storm systems that are hidden on the weather map. So let's take a look. This is how things look this evening. This is up at about 3 kilometers, 500 millibars, about 18,000 feet. We can see that that low off California is not really a low. It's more of a broad trough. And the axis runs about like that, and it is showing an advection lobe as far as the vorticity patterns go, and probably, I don't know, that could be convection, but something out ahead of that too. Anyway, that will be progressing eastward. These open waves do tend to move faster than closed lows, and I did look at 700 millibars, 850, 300, and it was not closed at any level. So this should continue progressing towards the east. The downstream ridge located right there, and as we know, we would expect to find some sort of frontal system in between. Actually, this looks like a ridge right there, so I might back that up and maybe bring that through here. So that's where I would look for maybe some sort of weak front. Now, does that exist? Well, the best thing to do is go to the 850 millibar temperature chart and see what's going on there. And we're bringing that up. And indeed, yeah, it does look like there's a little bit of thermal gradient in through here. And you can see a bit of cyclonic curvature, maybe a closed low over the deserts of California there. And this would suggest an 850 millibar front running maybe something like that, maybe a little further north. So is that reflected in the pressure and thickness chart? Not very much. There's a couple of thickness lines, and we do tend to see that during the cold season. But I think in this case, we probably do have kind of a weak front moving through Arizona. And the next stage of picking this apart would be to look at the water vapor imagery. And yeah, there's that system there moving across the southwest deserts. We can see that classic baroclinic shape. That's that baroclinic leaf. And we tend to find the vorticity max on the backside of that pattern. So the cloud field here, a lot of that's coming from warm air advection. Some of this is also going to be convective instability. And that's moving across Arizona this afternoon. And in the rear of that system, here and maybe back in here, that's the cold air advection in the back of the cold front. So this would suggest that the frontal system is looking kind of like that right there. So are we finding that on the surface chart? Well, not very much. So for now, I would put in symbology for a front aloft, and then I might look at some of the surface data to see if I can pin that down in the lower levels. So let's see how things evolve overnight. Just more west-northwest flow across the northern states, the jet located well up to the north, and a southern stream located right there. So this is a split flow pattern. That trough will be approaching Texas, and that means it's going to interact with some of the Gulf moisture. It may not be at the surface due to the cold dome covering Texas, but it is just off the surface, either at 925, 850, or even at 700, depending on how thick the cold air is. So that's going to be flowing north over that cold dome. You've got the lift approaching from the Chihuahua area of Mexico, and that means that we're going to have some interaction as we get into the last part of the week. And that may come as early as Thursday evening. And we look out to the west, and there's a couple of other disturbances moving inland. So this is going to bring rains to Northern California later on Thursday, And that polar vortex has really geared up over the Winnipeg area. Let me back that up and see how that comes together. Yeah, a little Fujiwara effect taking place there. The whole thing is part of the polar vortex. This is kind of like a subset. This isn't like a big storm that moved down from the Arctic. It's nothing like that. This is just a large mass of cold air. And this is the reflection aloft. So, yeah, these little systems spin, the basic center of it located right there, and that will bring another wave into the Dakotas around Thursday. And then this other piece will be moving south. Looks like it couples with this wave right here. And meanwhile, we've got that system from California moving towards Texas. So possibly some interaction with the cold air, maybe some isentropic lift over the cold dome, and maybe a little bit of elevated convection with that. So, yeah, this little piece of the polar vortex moving into Minnesota over the weekend. So it does look cold. And here comes our next disturbance. Seems like these are coming in at 2 or 3 day intervals. And this one's really deep there. The jet will be running out over Texas. And this flow is fairly channeled. I don't really see much in the way of deep advection lobes moving eastward. But we will pick up this area of positive vorticity as the warm air advection increases, as we get the upper level lift working over that area. And that's going to mean things are going to go downhill in Texas around Sunday or Monday. And then you can see the flow becoming more zonal, and we've kicked out that polar vortex, and it's pretty much out of the picture. So things will be moderating as we get into the last half of February. And then it appears we see kind of a succession of systems coming in from the Pacific. So we might get into a little bit of stormy weather during the second part of this month. So now if you want to take it one step beyond, you can go to Pivotal Weather or Tropical Tidbits or weathernerds.org, whatever your favorite site is, and run through the GFS forecast sequence looking at the surface charts. And check that out and refer back to that upper air discussion and try to pick out how that all links together. And just to kind of jumpstart you a little bit, you're going to be looking for these southern track systems. Remember, we saw those on the upper air panels. And if you kind of compare that with the surface charts, you're going to see those storm systems crossing the Rockies and heading out towards the Gulf. And that's all for this edition of Forecast Lab. I want to thank Ross Reynolds and Michael Rose for your Patreon signups. That, of course, will help support and sustain the program. So stay warm and take care, and we will talk to you tomorrow. Bye-bye.